Okay, this is going to be the exam review for the first exam, questions 31 through 40. So another, I think that's 10. We'll see. We've been doing a lot of these. So we have the price of a barrel of crude given with a function. So P is our price. We are asked where T is time, years, and such and such. So we want to find P of T, P prime of T, which is the derivative, and then we also want to get the derivative at 22. So to get the derivative, we use our sum and difference rules, the power rules, right? So we take the exponent, bring it down in front. So we're going to have 0.27 times 2, the 2 came down, and then we get t to the 2 minus 1, which is t to the 1 power. Okay. And then for the second term, the 1 comes down, so we have 1 times 8.6. And then we get t to the 1 minus 1, which is t to the 0. T to the 0 is 1, so we don't, so there's a sort of times 1 here, the t's gone. And the last, the 93, that's a constant when you take its derivative at 0. So we could put a plus 0 on the end, but we generally don't. So we just need to multiply this front part. 0.27 times 2 is going to be 4054. So 0.54 t minus 8.6. So that is our function, our derivative, and we put that into here. To find out what the derivative is at 22, we can now plug it in there. And just to be accurate, let's go ahead and do that with a calculator. So we're going to just go back to the main screen here. 0.54 times 22 minus 8.6. Okay, make sure you've got the right negative. Should give us 3.28. Now remember, a derivative is a rate of change, so that means it's so now we've got to say what if the price of a barrel of crude oil was increasing, because it's positive, right, at a rate of $3.28 per year in, now 22 is 20, that's what is T? T is time in years since the start in 1980. So we get 1980 plus 22. So there's 2, there's 0, carry the 1, 2002 in the year, per year in 2002, not just 22. Okay, so there's our first one. Second one, median home price is given to us, approximated by this function here. That's what we're going to focus on. Basically the same type of problem. Find the derivative of the function and then find the derivative at a particular point. And those are in thousands of dollars per year, thousands of dollars per year. So that's good. The units will stay the same. So again, taking the derivative, not f, we'll do p prime of t. The 2 comes down, 2 times 4.5. We'll go ahead and do that, double 4.5, you get 9. T to the 1 power, because 2 minus 1 is 1. When you take the derivative of a t to the first power, we're just going to get the coefficient, so minus 15. Again, t to the 0, which is 1, and then a derivative of a constant is 0. So you could put plus 0, but we don't need to. So this is our function here, 9t to the first minus 15, right from there. Now what we do is to get the derivative at 2, we evaluate our derivative function at 2. So it gives us 18 minus 15, which gives us 3. So $3,000 per year at 2. And since T starts at 2010, adding 2 years to that gets us to 2012. So at a rate of $3 per year in 2012. Okay. Now this one, we're given a graph. Let's see what we're asked to do here. The number of Facebook members in started 2006 to mid 2008 can be approximated by this function. And again, notice we've got some data values, and this is an approximation with T equal to 2004. Now, okay, so T equal to T0 equaling 2004. So that's going to be important for our answers, I'm sure. So they want, first of all, just the derivative of the function we've got here. So S of T is given, so the derivative of S, again, take the derivative step by step. The 2 comes down, so that's 2 times 15 is 30 T. 2 minus 1 is 1, so that's what's that. When we get to the second term, negative 76, the 1 comes down, so you get minus 76, T to the 0, which is just 1, and then you add 0 because derivative of a constant is 0. So there's our function. First thing they wanted us to compute, we put that here, 30T minus 76, not too bad. According to the model, how fast was Facebook membership changing at the start of 2007, which is T equals 3. So they wanted to be careful to give the correct, so this is in million members per year. This is membership in millions. And if we go up here, we just want to make sure millions of members. So we can just use the value we come up with S, okay? So we plug it into our function. This is in millions of members. T is equal to 3, they told us, because it's starting in 2004. And remember, you could have calculated that if they didn't give it to you. 27 minus 2004 is 3 years, minus 76. We're going to get 30 times 3 is 90. 90 minus 76, that's 4, that's 14. So in 2007, they were growing at 14 million members per year. 14 million members per year. So what they give us. According to the model, Facebook membership did which of the following? So the model, so we were decreasing. Now remember, this is 2006, so we decreased till maybe partway through the year, and then they started increasing. Here, the year 3, this is the 2007. So let's see, decreased at a faster and faster rate during 2007. No, it's a positive number. It's actually increasing. Increased at a faster and faster rate during 2007. Okay, so during 2007, so that's this period. Yeah, it's going to get crashed. Decreased at a slower and slower rate, increased at a slower and slower rate. So the increase actually is getting, if we were to draw all these tangent lines, it is increasing, and the increase is going faster. Increased at a faster and faster rate. So the rate is getting faster as we go through that. Okay, because the tangent line is getting steeper. Okay, now we get into our marginals. So this is going to be like, what was this? Was 11 point, this was 11.2, right? So everything else was 11.1. Find the marginal cost, marginal revenue, and marginal profit. So marginal cost, so we're given, here's the cost function, here's the revenue function. So marginal cost is the derivative of the cost function. Derivative of cost is 3x, derivative will be 3. Okay, x to the 0, which is 1. So there's a 1 here, 1 comes down, 1 times 3 is 3, x to the 0 is 1. The marginal revenue function, so we take this derivative, we take the derivative of 9x, so there's a 1 here, 1 times 9 is 9, x to the 0 is 1. There's a 2 here, so the 2 comes down, 2 times negative, so it's still negative, 0, 0, 2. 0.01 times 2 is 0.002. 2 minus 1 is 1, x to the 1 power. So there's our marginal revenue function. Marginal profit is revenue, and in this case we can do directly, it's a marginal revenue minus the marginal cost. So it's going to be this function 9 minus 0.002x minus 3. Okay, so 3 is the cost. So 9 minus 3 is 6, so we could rewrite this as 6 minus 0.002x. There is our marginal profit. For all values of x for which the marginal profit is 0, find all which is 0. So we take our marginal profit, right? That's what they're looking for, yes. So we take 6 minus 0.002x. It's a linear function. It's only going to be 0 at one place. We set it equal to 0. Now I'm just going to add the 0.002x to both sides. It saves maybe a step. So we get 6 equals 0.002x. Divide both sides by 0.002. So we're going to get x equals 6 divided by 0.002. That's going to be 3, and that's at 300 or 3,000. I think it's 300, but let me just be absolutely sure. 6 divided by 0.0, is that, maybe that's going to be thousands, right? 3,000. That's why I always do this. Too many zeros on top of doing too many problems. Don't take a chance on that and putting just the 300 because, oh, there's only 2 zeros. Well, now we're in the thousands place. Think it through. Especially on tests, you're just doing so many problems. So it's like the putt, the golfers, they get down to that last putt, even though it's just a few inches, take the time, set it up. Okay, so 35, a little more involved here, but we're going to get marginal revenue, marginal profit. So we're given a cost function. They don't give us a revenue function. What's going on here? Well, as we read through, the society will charge students $1.10 per serving of pasta. So everybody's going to pay the same price. The revenue function is at each student, where x is a student, it's going to cost $1.10 per student. So our revenue function is simply 1.10x. Okay, so calculate the marginal revenue. Well, the marginal revenue here is just going to be the cost for the revenue we get from the next student is still $1.10. It kind of makes sense. You're not giving anybody a discount. You're not charging anyone extra. Everybody pays $1.10. Now calculate the marginal profit. Well, to get the profit, we have to take the revenue minus the cost, or the marginal revenue minus the marginal cost. Let's go ahead and just calculate the marginal cost, even though they don't ask for it. It'll make our calculations a little easier, because when we get the marginal cost, one term will drop off. The constant term drops off. That's 350. It's gone. Derivative of the middle term is just an x, so when one comes down, it's going to be 0.10 x to the 0, which is 1. And then we're going to get plus, again, the 2 comes down, multiplies in the front here. So 2 times 2 is 4, so we get 0.004. 2 minus 1 is 1, so it's x to the 1 power. Okay, so there's our cost function, revenue function. Now be careful when you do this subtraction to get the profit function, the marginal profit function directly. It's going to be marginal revenue, 1.10, minus the marginal cost. Now this negative has to distribute through. I've just seen too many times where a student will have everything else set up correctly but does not put this parenthesis, so it doesn't get distributed, and again you get an incorrect answer. So this negative will come here. So we get 1.1 minus 0.1. So 1.1 minus 0.1 is going to just be $1 minus 0.004x. Okay, so that's our marginal profit. Compute the revenue and profit and also the marginal revenue and profit if you have produced and sold 200 servings. Okay, 200 servings in a pasta. So we do need the revenue. Revenue's up here. Again, this is not, these two are not marginals. These are not, we're not looking at the derivatives. These are the originals. So they did not give us the original profit function, so we're going to need to maybe backstep and actually do that. I didn't do that either, but it's going to be profit is revenue minus cost. So anyway, revenue, the way we calculate that is just 1.1 times 200. So that 1, 2 moves the decimal over 2 places. 1, 2 would be 110, so 220. Profit is going to be, again, revenue minus cost. Since we're getting exact ones, you could, the profit is going to be that. So it's going to be 1.1x minus, and again, remember this parentheses, in this case, 350 minus 0.1x plus 0.002x squared. Okay, so we're dealing with the profit function, not the derivative. Plug in 200, you'll have your answer. So this is going to be our 220 minus, and notice I'm going to go ahead and do this calculation all together and then just subtract at the end. This is 200 times 0.1 is going to be 20. And you plug in 200 here, 200 squared. Again, I'm going to make sure I don't make a silly calculation error by not checking my work. So 200 squared should be 4,000, 40,000, 40,000, 40,000. And then we multiply that times 0.002. Brings us back down to 80. Okay, so this part here is 80. So notice I've got the negative out there, so 350 minus 20 plus 80 is going to be 350 minus 20 is 330 plus 80 gets me to 410. So we've got 220 minus 410. We're losing money at 200 students. So we'll subtract the 220. And we know it's negative. Actually, it's negative 190. So profits negative 190. Now we want the marginal revenue per plate at 200. Again, the marginal revenue is 110. So we're back up here. We're going to use these to get these values. So there's no X value to plug in. It's just $1.10 per student. The marginal profit, we're going to plug in. So we got 1 minus 0.004 times 200. That's going to be 80. No, it can't be 80. 8 maybe. So I go 0.004 times 200. Let's just do it this way. 0.8. That makes more sense, yeah, because you can't lose that much money. And so 1 minus 0.8, you're going to lose 20 cents. You're losing 20 cents at this point per plate. So you should be up in the cost. But, you know, maybe you've got some donors, something, you know, you got a grant. So the approximate loss from the sale of the 201st plate is 20 cents. Now, when you do this drop down, you will select loss. Loss is a negative, so then you don't put the negative here. Okay, I'll review this, but there should not be a negative on here, even though, again, it is a negative value, but you're incorporating that in this, in the drop down. Okay, for which value of X is the marginal profit? 0. Well, okay, now we take our marginal profit, 1 minus 0.004x, we set it equal to 0. Again, we'll add 0.004 to both sides. So it gets 1, and then you take 1 divided by 0.004, and it's going to get you about 4,000. 1/4, not 4,000. A fourth will be 2,500. I think that's what we got to get. So we take 1 divided by 0.004. 250. So we're getting there. We just have to serve enough people. So it'll be, the marginal profit will be 250. If you serve 250, we'd have to look at the, actually, so we're having a loss, 250, we have 0. The graph of the profit function is a parabola, right, because it, see, we looked at the profit itself. Where did we come up with that? We sort of came up with it here. This would be a parabolic. And it's got a positive on the x squared, so it so we know that it opens upwards. So there's a minimum profit, and then after that point, it would be better. So the graph of the function is a parabola with a vertex at 250. So the marginal profit is there. So that's what we're finding, where remember, the slope of the tangent line would be 0. So the loss is a minimum when you produce and sell 250 plates. Actually, this is all going to be negative. So that's right, because this is negative would come here. Sorry, the graph, if we were to graph it all, would like this. But again, this is all a loss. The place that you minimize the loss is at 250. But so you're not going to raise much funds. You're going to lose a lot. But after 250, you start really losing more. Okay. Okay. So let's see, what time is it? I got a few more minutes. Let's see if I can finish these up. Calculate dy dx. Simplify your answer. So this one's just finding the derivative. This one we're into 11.3. We're using the product rule. So we want to see that we've got two different functions here. So we'll call them f and g. So f of x is x to the third. The derivative of f of x will be 3x squared. G of x is the second function, which is going to be 9 minus x squared. And so the derivative of g of x, derivative of 9 is 0. Derivative of negative x squared is going to be negative 2x. Use the formula for the product rule that the derivative of f times g is equal to the derivative of f times g plus the original f times the derivative of g. Okay, derivative of f is 3x squared times the original g, which is 9 minus x squared, plus the original f, which is x to the third, times the derivative of g, which is negative 2x. They do say to simplify our answer, so we're going to follow through. So we distribute the 3x squared. So that's going to give us 3 times 9 is 27 x squared. And then we have x squared times x squared, so we'll get a minus 3x to the 4th. Here we're going to get a plus, but then we're multiplying by a negative, so we're going to get a negative 2x to the 4th. So our final answer should be, it's going to go down like this, it's going to be 27x squared. X to the 4th are like terms, so we get a minus 5x to the 4th. Okay, 37. This is going to be a quotient rule. And so we've got a numerator over a denominator. So the numerator is 3x plus 7. The derivative of the numerator will be just 3. The denominator is 5x minus 1. The derivative of the denominator is just going to be 5. And then just remember, when we take the derivative of the numerator over the denominator, we get numerator derivative times denominator minus numerator times the derivative of the denominator. So we're switching off there. And then we get the denominator squared. So let's put this all in, then they want us to simplify. So the numerator, the derivative of the numerator is 3. The denominator is 5x plus 1, 5x minus 1. Okay. Then we have a subtraction. We put the whole numerator, 3x plus 7, times the derivative of the denominator, which is 5. That's all over the denominator squared. 5x minus 1. This doesn't factor, which is good. Okay, so we distribute here. The 3 times 5 gives us 15x minus 3. Here we're going to distribute a 5, but we're also distributing a negative, so we get a negative 15x minus 35 all over 5x minus 1 squared. So 15 minus 15 of the x's, so those become 0. Negative 3 minus 35 is going to be minus 38 all over 5x minus 1 squared. And that's simplified. 38. Okay, so we've got a product rule here. So this is we'll call this F, we'll call this G. So remember, f of x, if you want, we'll just make the notation a little easier. So if that's our function, our derivative of f, 0.8 is going to come down, so you've got a 0.8x, subtract 1 from that, so you're going to get a minus 0.2. 1 comes down, so you get a minus 2x to the 0, which is that, and then the derivative of the negative 5 is 0, so that's it. So there's our derivative of f. G is this other function here, x minus 1 plus x to the minus 2. So when we take the derivative of g, we get the negative 1 coming down, so negative x, and then subtract 1 from the exponent, so it becomes negative 2. For the second part, the negative 2 comes down, so this becomes minus 2. Subtract 1 from the exponent, negative 2 minus 1 is actually negative 3. So there's our derivative of g. And then just remember, and it's helpful to write these multiple times. So derivative of f times g, it's going to be the derivative of f times g plus f times the derivative of g. You need not expand your answer, so I'm going to follow through. That's cool. So derivative of f, I'm just going to write it here without expansion. X to the minus 0.2 minus 2 times the g function, the original g function, right, which is up here, x to the minus 1 plus x to the minus 2. We also don't have to change these to positive exponents, it doesn't say. Then plus the f function itself, so we just rewrite that, x to the 0.8 minus 2x minus 5. That's the f function, and then the derivative of g, so we have minus x minus 2 minus 2x to the minus 3. And I'll fit in there. So that's what goes in there. 39 and 40.